Recording started.
Hi, sc14 students. We're going to do a recording here that's going to help you review for the midterm exam. This will be a very important test for you because it's the first test that we have for this semester. I believe it's on lessons 6 to 9, but I'll check that for you. So we're going to go over some stuff now, and as we're doing this, if there's any questions that you have that you come across as we're doing the recording, just let me know. I'm going to be asking some blue questions in the recording, and I won't be giving you the answers for them, but after you watch the recording, you let me know that you've watched it. Just let me know by an email or something like that, and then I can send you over the answers for the recording. Okay, so let's get into this stuff then. It says when two objects rub together, this produces friction. So, for example, if you rub your hands together, you get heat between them caused by friction. So friction is when the rough parts of two surfaces slide past one another. You probably know that in your engine there's friction going on because of the moving parts. So whenever friction happens, as we know, heat is produced as well. Okay, so I just got two questions for you to think about. When does friction happen is the first question, and the second question is what does friction produce? Okay, so think about those two. So you can see a diagram here now. This diagram is illustrating something called Brownian motion, and that's when particles zigzag all over the place when placed in a liquid. Now the reason why the particles are moving is they're bumping into molecules that are in the liquid. So that's what Brownian motion is all about. Okay, it's the zigzagging that's taking place because particles are bumping into molecules in a liquid. Okay, so the first question, what is Brownian motion? And the second one, what causes it to occur? Now, when we talk about energy, energy comes in different forms. For example, if you lift the ball onto the counter, that gives it what's called potential energy. The reason why it has potential energy is now the ball has the potential to fall and will move as it falls. When the ball starts falling off the counter, it will then have kinetic energy, because kinetic energy is the energy of any moving object. Now, if you were to take the ball and stick it in an oven, it would then have thermal energy, which of course is just another name for heat energy. That's a lot of things we're doing to that ball, right? Okay, so first question here, define kinetic energy, and then define thermal energy. Now, have you guys ever heard somebody say something like, don't leave the window open because you'll let the cold in? Did you know that's actually impossible to let the cold in? The reason is because it's always heat that's moving from one place to another. So heat always moves from wherever there's lots of heat to wherever there's little heat. It's not actually cold that's moving, it's heat that's moving. So if you leave the window open, heat is actually going to move from you, because you're warmer, to the outside where it's colder. And that's actually what makes you feel cold. All right, so the question here, question 7 says, describe which direction heat flows when it flows from one object to another. Question 8 says, what is the main job of insulation? And the next question, how is it different in the summer and winter? That is insulation. I think we covered that in the last question, insulation. And maybe we didn't. Okay, so what insulation needs to do in the summertime, it needs to prevent the heat from getting from the outside from getting in, and in the winter it prevents the heat from leaving the inside of the house to go to the outside of the house. Now, when we talk about insulation, we talk about something called R value, and the higher the R value, the better an insulator is. So an insulator with a high R value will keep you cool in the summer and warm in the winter. All right, now let's talk a little bit about temperature. Temperature is related to kinetic energy. And again, that's the energy that moving objects have. So the higher the temperature, the higher the kinetic energy. And that's because as you heat objects up, they have more energy to move around. Now, temperature actually measures the average kinetic energy of the particles, and that's really important to know. So we're going to look at a picture here that kind of illustrates that. So if this rectangle that you see was a bathtub filled with water, as you can see, the particles would have different temperatures and different amounts of energy, right? But most of the particles are around plus 14. So this illustration here is showing why temperature is the average amount of kinetic energy that the particles have. Their average is around plus 14. Now remember, the larger the object, the more heat energy it can hold. So if you've got a 10 kilogram metal object, it can hold a lot more heat than an object that's made of the same material that's only 1 kilogram, right? Okay, so again, a few questions here. The first one, explain the relationship between kinetic energy and temperature. And question 11, explain what it means when insulation has a high R value. Is that good or bad? What does it do for you, having a high R value? Okay. Now remember, there are different ways that heat travels from one object to another. There's different sorts of what you call heat transfer. One is called conduction, and that's how heat travels in a solid. For example, if you think about the heating element of a stove, if you put something on a stove, that's going to be conduction. Heat is moving from the element to the pot. Now specifically, metals are good conductors, while other solids like plastics are poor conductors. There's another C word, which is convection, and that's how heat travels in liquids and gases. And when we think about convection, we think of a convection current going around and around in a circular motion. So when you heat a liquid, the hot particles rise, and then they cool. When they cool, they fall again. So you've got this continual cycle going on. So again, it creates a circular motion called a convection current. The same thing happens with gases as hot air from the heat register on the floor rises to the ceiling and then drops again. So again, convection current happens in both liquids and gases. So the first question we have, explain what types of substances make the best conductors. Question 13, explain what substances convection occurs in. And question 14, explain where a heater should be placed in a pool if you're wanting to heat the water in the pool. What part of the pool should it be placed in? All right, the next sort of heat transfer is radiation. And so radiation is heat traveling not through solids, liquids, or gases, but through space. So when you're talking about the heat from the sun, that's radiation. The heat is actually traveling through thousands of miles of empty space. So again, radiation is through empty space. All right, so if you see this picture here, you see the reflective surface that's used in walls. Okay, and then you see these other diagrams here. See how in the winter time the shiny surface keeps the heat in the room so it can't pass through the walls? So question 15 here says, explain what type of heat transfer is prevented by putting foil insulation in walls. So again, what kind of transfer does that prevent? Is it conduction? Is it convection? Or is it radiation? Excuse me. All right. So have you ever wondered why they put feathers in a, like a winter coat? Why do feathers make good insulation? Well, the reason is because there's air between the feathers. And the thing is that the air is not moving. Remember, it's only moving air that can take heat from one place to another. So if air between feathers is not moving, or you call it dead air, then heat that's in your body is able to stay there. So a feather-filled jacket doesn't allow the heat to be transferred through the feathers. Now this is the same reason why sawdust makes better insulation than solid wood, because you've got dead air in between the sawdust particles. All right, so the question here is explain why feathers or other things with space in between them are good at insulating objects. All right, so now we've got a picture. It's got a white rectangle and a black one. And I'm just wanting to point out that dark-colored objects attract heat, while white or light-colored objects reflect heat. And of course, that's why we wear light-colored objects in the summer. Now, we talked about the idea before that large bodies of water moderate climate. So we're talking about things like oceans. So what they do, if you have a large body of water beside you, it makes your climate less cold in the winter and less warm in the summer. So of course, if you think about the type of climate that Vancouver has, it's got what you call a moderated climate because of the ocean. Now the reason that happens is because water has a high heat capacity. So what does that mean, high heat capacity? Well, it means it takes water a long time to heat up and a long time to cool down. So that's why Vancouver's less cool in the winter and less warm in the summer. So in the winter, the water takes a long time to cool down, and in the summer, the water is taking a long time to heat up. All right, so question 16, explain why Vancouver is cooler in summer and warmer in this winter time. Again, it has to do with water, right? So, question 17, explain how water having a high heat capacity relates to how water cools down and warms up. Question 18, why do you think water is used to cool a car's engine? How would that benefit you? Question 19, if you had two objects in the sun and one had a high heat capacity of 10, or had a heat capacity of 10, and the other had a heat capacity of 5, which object do you think would heat up most quickly? Okay, so go back to the definition of a heat capacity. And question 20, which object would absorb more energy? All right. Now at this point we're going to talk about levers. And you might remember levers come in 3 different classes. And the way we think of the difference between the levers, there's something different in between the levers, in the middle of the levers. Okay? So the parts of a lever are the load, that's the amount that's being lifted by the lever, the effort, for example, if you're pressing on the lever, the amount of force you push on the lever is the effort, and the fulcrum or pivot, that's the part that's in between. So this, for example, this lever looks like a teeter-totter, right? Okay, so in this case, for a class 1 lever, the fulcrum or the pivot is in the middle. For a class 2 lever, the load is in the middle. And for a class 3 lever, the effort is in the middle. Okay, so you need to memorize these so you can recognize the difference between the 3 classes. And remember what's in the middle. If you can remember what's in the middle, then you'll remember what the other 2 parts are, as long as you know what all 3 parts are. Okay? So, which type of lever do you think a teeter-totter would be? Class 1, 2, or 3? And which type of lever do you think your arm would be? Class 1, 2, or 3? All right, so think about that. Okay, we talked about simple machines before, and you can see all different kinds of simple machines. So it's important to know these different types of simple machines. Now, do you remember what the difference between a simple machine and a complex machine is? Well, a simple machine has only one type of movement. So any one of these machines that you can see above only have one type of movement. Whereas if you think about a bike, it's a complex machine because it has many different simple machines put together. Now, one part of a bike is a wheel and axle. And that's a simple machine, right? Okay, so question 23 says, think of another example of a wheel and axle. Can you think of one in your room? How do you get out of your room? There's a hint. What do you open? Okay, there's a part of that that's a wheel and axle. And how about a pulley? What's a pulley used for? Okay, we're just going to talk at this point about work. Now, normally in everyday language, if we saw a lady pushing on a fridge like we do in this picture, we would say she's doing work. But the thing is, in science, if she's pushing on the fridge but she doesn't actually move it, she's actually not doing any work. Because in science, work is equal to force times distance. And see, she can be pushing on the fridge with a whole bunch of force, but if she's not moving at any distance, the amount of work, according to science, is zero. So also remember that energy and work are related, because energy is the ability to do work. So she is using energy. All right, so question 26 says, what's the definition for work according to science? And how are work and energy related? All right, so guys, we've done all the questions, and I hope you've enjoyed this session. So what I'm going to do is later on I'm going to post the answers. As soon as you guys let me know you've watched the recording, I'll send over the answers to you. So I would study these really hard, make sure you can get all these answers. Watch the recording a few times so you've really got it in your mind. And again, it's really important to do well on the midterm because it is your first test. So take care, guys, and have a great day. Bye for now.